Good evening. Last class. Last time we looked at polar curves, right? Now we're looking at the calculus of polar curves. Trying to find dy dx. So slope. Well, remember that if you're given a parametric equation, parameterization, dy dx was dy dt over dx dt. Now suppose you're given r equals f of theta. And we again now want dy dx. Well, if we look at this as a parameterization, parameterization of a circle is r cosine theta, r sine of theta. R is f of theta, though. So we can think of the polar curve as a parameterized curve, specifically the parameterization f of theta cosine of theta, f of theta sine of theta. The domain of theta is going to be whatever the domain of R is. Well, then we can just use the derivative for parameterization. What is the derivative of y with respect to theta? The product rule, right? There's dy dx. So if we ask for the slope of a polar curve at a specific point, there's your formula to find dy dx. Then you just have to plug in what theta is. To start here, find tangent lines of r equals 1 plus sine of theta at the 2 points. Point where theta is 0 and the point where theta is pi. And that is the form we're looking for. Now let's just make some adjustments. Dy dx at theta naught. X minus x naught. Well, x is f of theta cosine of theta. Right, and y was f of theta sine of theta. So there's what we're looking for. And so I'm just going to jump right into y. Dy dx. Derivative of r times sine. And the derivative of r, cosine, right? Then it would be r times cosine. Divided by dr d theta times cosine of theta minus r times sine of theta. Well, that's going to be times x minus f of theta, r times cosine of theta. Plus r times sine of theta. We want to evaluate that at 2 points. So let's say at theta equals 0, we just plug in theta equals 0. Sine of 0.
Do 1.
Zero. That first term is 0. This term down here is 0. What's cosine of 0?
Pi over 2.
1. Inverse cosine of 0 would be pi over 2. 1 times 1 is 1. 1 times 1 is 1. Slope is 1. Oh, and look, and that's 0. So the tangent line is just y equals x minus 1. At theta equals pi, what is sine of pi? It's 0. So once again, 0, 0. What's cosine of pi? Negative 1. Get negative 1 in the numerator. Negative 1 times negative 1 in the denominator. Slope is negative 1. Again, negative 1 times 1, positive 1. I'm sorry, it's negative 1, but then we have the minus, so that's where the positive comes from. And y is 0. Tangent line, oh, I forgot the y equals. Tangent line is y equals negative quantity of x plus 1 or negative x minus 1. Now looking at the polar curve, r equals cosine of 2 theta. Want the tangent line at 4 points. When theta is 0, when theta is pi over 2, when theta is pi, and when theta is 3 pi over 2. dy dx r prime times sine of theta plus r times cosine. I just realized this is not going to give me enough room. Right, that is going to be divided by r prime times cosine minus r times sine. X times x of theta, which is r cosine of theta, plus y of theta, r times sine of theta. All right, so that's the form of our tangent line. At theta equals 0, sine of 0 this should have been a 2 theta, not that it's going to change my result. 0, 0. Negative 0 minus 0 is 0, isn't it? If the numerator is also 0, we don't have a tangent line. Is the numerator 0? Now what's cosine of 0?
1.
So is the numerator 0?
No.
No. What's the numerator?
Two. 1.
It's 1. This is 0, right? That term's 0.
We wish to.
1 times 1.
Do you do anything with that 2? That cosine 2 theta?
What's 2 times 0?
0.
Cosine of 0. Remember, that's cosine of 2 theta.
Okay.
You get a slope of 1 over 0. What does that tell you the line is?
Straight.
All lines are straight by definition.
With me. There is no angle at all. It's like horizontal. No.
Horizontal would be a 0 angle. Because remember, what is slope? Rise over run, isn't it? So change in y over change in x. If change of x is 0, what kind of line do you have? It's a vertical line. We say that's infinite slope. So there is a tangent line, it just happens to be vertical. Which means the line is of the form x equals something. We have to figure out what that x is. Well, that's easy enough. X is cosine of 2 theta times cosine of theta, right? And at 0, we said that was what?
1.
1. X equals 1 is your tangent line. Let's look at pi over 2. Cosine of pi over 2.
Zero.
This term is 0. That term is 0. What is sine of pi over 2? So we're going to have a -1 in the denominator. Yeah. No, +1. No, -1. I'm thinking that sine was -1. Because cosine of pi, -1. Yeah, so it would be +1. Minus -1 times 1. Right, because remember, that's 2 times pi over 2. So +1 in the denominator. What's sine of pi?
Zero.
Which means that term's 0. Your numerator's 0. Which is a horizontal line. Where does it occur? Well, y is cosine of 2 theta times sine of theta. Cosine of 2 theta, we said, -1 times 1. So the tangent line is y equals -1. Sine of pi is 0. So that's 0. That's 0. What's sine of 2 pi?
0.
That's 0. Once again, the denominator is 0. As long as the numerator is non-zero, it'll be a vertical tangent line. So the question is that term 0 at pi? Nope, it's not. We have a vertical tangent line. What is cosine of 2 theta times cosine of theta at theta equals pi? Well, it's what? Cosine of 2 pi times cosine of pi? -1. Now at 3 pi over 2, cosine of 3 pi over 2
0.
those are 0. What is sine of 3 pi?
Zero.
That term 0. As long as that term is non-zero, we have a horizontal line. Is that term non-zero? Right, so cosine of 3 pi times sine of 3 pi over 2. Is that 0? Nope. This is a horizontal line. What is cosine of 3 pi times sine of 3 pi over 2?
1.
It's +1. So there are now 4 tangent lines. Was cosine 2 theta. Theta goes 0. It's pi, right? 1 period would be pi. So we have 4 tangent lines, x equals -1, x equals +1, y equals -1, y equals +1. Let's just go -2 to 2 all the way around. Oops. Good, it wasn't shift enter. What color do we want to make the tangent lines? No one has a color in mind?
Red.
Red? What did you say?
Blue.
So let's mix the two. Say purple. Do we want them to be solid lines, dash lines? You know what? Let's just keep it solid. Why not? And let's turn the frame off. Well, that's not right. Apparently I do have to go up to 2 pi to get the full picture. So there are our 4 tangent lines with the polar plot of cosine of 2 theta. By the way, each one of these loops is called a petal. Let me know before I go into that. So let's say we're given a polar curve, r equals f of theta. We want to find the area inside r equals f of theta bounded by the rays theta equals alpha and theta equals beta. Area is a half the integral from alpha to beta of r squared d theta. Now, why? There we go. Or you may see it written as f squared of theta d theta. They're the same thing. To find the area of the region that is shared by the circles r equals 2 cosine of theta and r equals 2 sine of theta. Oh. 2 pi. And it's still, because, oh my goodness, that should be theta from 0 to 2 pi. I'll get this right eventually. There we go. So that's the region we're looking for. That's what the area we're looking for. Doesn't that ray perfectly divide the region in half? So actually what we can do is find the area of either that lower half or the upper half and double it. Let's go with the lower half.
Can we find the area under the upper function? And then under the like bottom function, like substitute one for another.
What do you mean? To find the area
Like
of
if we
the...
take integral of the function from of 2 sine from 0 to 1, we'll find the area under.
Why are you doing 0 to 1?
Because
And why is it 2 sine? Should be 2 sine all
Yeah.
squared.
2.
Because remember, when you're doing area of polar curve, it's different.
Oh yeah.
It's not just the integral of the function. It's the integral of the function squared. Half of the integral of the function squared.
So we can like use what we've done before. Okay.
If you want to convert those both to functions y equals f of x, you can. But that would require you to do that first. So all I'm going to do here is find this area and double it. I could find the area of both regions and add them together, but that's going to be symmetric, so I know the area is going to be the same. So what is this ray? What angle is that?
45
This one.
from 0.
That one is 0. What about this one?
45.
Can't use degrees.
pi over 4.
That'd be pi over 4. How do you know it's pi over 4?
Because the y-axis would be pi over 2, and then that looks like it's in the middle between.
Uh-oh. Looks like is not good enough.
Could we intersect? The other one?
You have to find the angle at which they intersect.
45.
Pi over 4 is where they intersect. Cosine theta equals sine of theta. Happens twice. At pi over 4 and at 3 pi over 4. Not 3 pi over 4. 5 pi over 4. Area is twice this area. And that area is 1/2. So twice of a half is 1. Integral 0. It's pi over 4 alpha to beta of r squared d theta. Which r are we using? Are we using 2 sine or 2 cosine?
Cosine.
2 times sine. So this lower circle here, right? Which is actually part of this larger circle, which is the 2 sine. Which is 4 sine squared. Because you have to square it. Use the reduction identity on sine squared. Integral of 1 from 0 to pi over 4 is just pi over 4. You'll get minus 1/2 sine of 2 theta. Evaluate that 0 to pi over 4. What is sine of pi over 2?
Zero.
1. What is sine of 0?
Yeah.
Area is pi over 2 minus 1. area of the region shared by the cardioids. R equals 2 times 1 plus cosine of theta, and R equals 2 times 1 minus cosine of theta. That's the area we're looking for. The way I drew the rays divides it into 4 regions. We have 4 separate areas defined. If you just look at that horizontal ray, these 2 regions would then be what? Same area, right? Now if you look at the vertical, Wouldn't those two regions also be the same area? So if we just pick one area to find and quadruple it, we get the total area, which is exactly what we're going to do. Again, it doesn't matter what region we pick. Yeah, that should work. So let's pick this region. This region is bounded by what two rays? This one and this one. So what is that ray?
Zero.
And what is that ray?
Pi over 2.
Four times a half. Integral 0 to pi over 2 of r squared. So which r are we looking at?
Three times 1 minus cosine.
That curve there, which is part of the 2 times 1 minus cosine. And remember, that's being squared. One minus 2 cosine of theta plus cosine squared and then again the reduction identity for cosine. So 8 times 3 halves from 0 to pi over 2 is 3 pi over 4. Minus 2 sine of theta from 0 to pi over 2 plus a quarter sine of 2 theta from 0 to pi over 2. What's sine of pi?
0.
What's sine of 0? That term evaluates out to 0. Sine of pi over 2.
1,
Sine of 0.
0.
That becomes 2 times 1. Distribute the 8 through. Area 6 pi minus 16. Okay. Area inside the Leibniz gate, r squared equals 6 cosine of theta. Outside the circle, r equals root 3. If we look here, r squared is 6 cosine of theta. Remember, polar plot, we can only do r equals f of theta. However, since r has to be positive, I'm fairly certain I can just do this. Just use square root of 6 times cosine of theta. And then the other one is square root of 3. Let's see if this works. Theta is going to go from oh, wait a minute. I think that's a typo. I think this is supposed to be 2 theta. Let me just try this from 0 to 2 pi. I think it's going to give me an error. It didn't. Perfect. Love it. Yep, and that is definitely the shape I wanted. So it was supposed to be cosine of 2 theta, not cosine of theta. So the area we're looking for. That's terrible. That area right there. Now what I am going to do is just extend that line in white just so we can see that that continues out to that curve to be root 3. These two regions, do they have the same area? Yeah, right. So find the area of this region and double it. But if I draw a ray here, top and bottom, are they the same? So if I just find the area of this region up here and quadruple it, I'll get my total area. Right, now, of course, the advantage of technology is you can see what that angle is. We're going to pretend we don't have it. Oops, no, I definitely did still want red. Well, that ray is obvious. So the question is, what is that ray? How do we find it? Set this equal to this squared. Cosine of 2 theta has to be a half. Now, first quadrant means that the ray is going to be between 0 and pi over 2. Which means we're only looking at a single angle. At what angle in quadrant 1 is cosine equal to a half?
Pi over 6.
Which is 30 degrees, which is what the ruler had. Again, you want to be careful relying on the ruler because that may not necessarily be drawn to scale if I give you a picture of the graph. Right, maybe for illustrative purposes, I don't set the origin at 0, 0. Or I just make one larger than the other. Four times a half, integral from 0 to pi over 6. But now we're looking at a region that's bounded by two polar curves, right? Zero to pi over 6. Which curve is larger? The circle or the lemniscate? Which has a larger radius? The lemniscate. Right? So you have to be careful here. Right? We're not looking at upper versus lower or left versus right. Well, I guess technically we're looking at one of those. What we're really looking at is distance from the origin. So draw a line from the origin. Which curve does it hit last? That's your larger curve. And now remember, it's r squared. So it's the 6 cosine of 2 theta that we're using. Then minus square root of 3 squared. Three from 0 to pi over 6. It's pi over 2. So sine of 0 is going to be 0. So it's going to be something minus 0. What is 2 times pi over 6?
Two times pi over 6.
Yep.
Pi by 3.
What's sine of pi over 3?
Square root of 3 over 2.
Times 3? There's the area. 3 root 3 minus pi. So I haven't been doing it, but really we should be making sure. Is that area positive? Yes. Has to be positive. Area is always positive. So that value is positive. Good. Is this value positive? Yes, okay, good. Is that value positive? Yes. Perfect. So it means we didn't screw up. But, all right, let's rephrase that. It means we possibly didn't screw up. Right? If you get an area that's negative, you know you screwed up. And so again, given a polar curve, r equals f of theta. Bounded by the rays, theta equals alpha, and theta equals beta. Arc length. Integral from alpha to beta. Square root r squared plus the derivative of r with respect to theta squared. Right? Or if you keep it in function form, f squared times f prime squared. Or not times, plus. Be careful with notation. They are not the same. This is the derivative of r, then squared. This is the derivative of r squared. Right? Just like they are not the same. This is the differential for r squared. This is the differential for r, then squared. Another thing you see common in applications with the delta notations, right? This is the change of r, then squared. The other one is the change of r squared. So you don't want to be lazy and forget your parentheses. Right? They have two totally different meanings. And then, by the way, there is that's also something, but delta squared is its own operator. It's a completely different operator. Doesn't even mean change. So you can't even try and shortcut and go, oh well, I'll just use this to be change of R all squared. No, that's something completely different. I think this is the Laplacian. If I remember correctly, I think that's called the Laplacian operator. You should study it in Calc 3. Well, not study, but you should be introduced to it in Calc 3. If you take partial differential equations, you would definitely see the Laplacian. We're going to find the length of the cardioid. R equals 1 plus cosine of theta. That means we're going to go 0 to 2 pi. Right, because they want the length of the entire cardioid. So 0 to 2 pi square root r squared plus r prime squared. What is dr d theta? Close. It's negative sign. Lucky for you, when you square it, doesn't matter. 0 to 2 pi square root 1 plus 2 cosine plus cosine squared, then plus sine squared. And we're left with the square root of 2 plus 2 cosine. Okay, or you can simplify it. The square root of 1 plus cosine. In fact, not the root 2. This is awful. If we had to do this by hand, we'd have to make a special substitution. I actually don't know what that substitution would be. But that's okay because I can cheat. Oh my God, really? I'm a dumbass. Can just use the half angle identity. Which is that. So you know what? I'm going to do this by hand. Technically plus or minus, depending on the angle, depending on where we're located. So I would have to right. So 1 plus cosine of theta square root of 1 plus cosine of theta would be square root of 2 times cosine of theta over 2. Would be the absolute value of that. And then this is where we're going to have to get clever. So cosine of theta over 2. I'm going to do a u sub. No. Right, if I make u theta over 2, du becomes 2 d theta.
Zoom from 0 to pi.
I'm sorry, d would be d theta over 2. D theta would be 2 du. That's why that doubles. And then, yes, it goes 0 to pi. From 0 to pi over 2, cosine is positive. From pi over 2 to pi, cosine is negative. However, aren't the areas the same? And integral is just an area. So it becomes 8 times the integral from 0 to pi over 2 of cosine of u du. What is sine of pi over 2?
Well,
Sine of 0.
0.
Length is 8. Always forget the half angle identities. That absolute value is important. Take away the absolute value, integrate from 0 to pi. You get 0. And that is because you're dealing with a signed, remember, integral is a signed area. So the two areas are equal, but opposite signs, so they cancel each other out. That's why that plus or minus is important. Okay, we got one more. I just don't care about the cardioid. We already know what that looks like, but this spiral might be in this thing's shape. I don't think it is, but let's take a look. It's just that. For 0 to pi, what happens if I extend this out? Let's go to 3 pi. Yeah, so as you extend this out, it's going to start to spiral around the y-axis. The problem is it's making the x-axis so small we're not going to see the entire spiral. What if I cut this in half, make it 5 pi? Yeah, not really going to But as it goes, it's spiraling around the y-axis. Just go to pi. So we're just looking for the length of essentially the start of the spiral. Integral 0 to pi, square root, r squared, plus r prime squared. What is the derivative of r?
It's gonna be particle.
Hmm?
It's gonna be particle.
No, is it? Why do you say product rule?
So we said, but is it 0 power?
Theta, e to the theta. Yeah, there's a horizontal line there to make it theta. It's pi just not, because of how small it is, it's not showing up on the screen. Because the pixels for that is crap. That's why they should probably just make every classroom, smart classroom, get that really nice TV in here. That's really got really nice definition on it. Taught that room once. That's a really nice room. I think it's LA 204. Has a really nice big screen.
Quotient rule?
Why quotient rule? I mean, you can use quotient rule, but what's the derivative of root 2? So you don't need quotient rule. Isn't that a scalar multiple? It's 1 over root 2 times e to the theta. What's the derivative of e to the theta? R prime is the exact same bloody thing. It's just e to the theta over root 2. Square it. What's the square root of e to the 2 theta? E to the theta, why no absolute value? Because remember, square root of x squared is absolute value of x. So why do we not need the absolute values?
Because e is positive and theta is between 0 and 5. So it can only be positive.
The fact that theta is between 0 and pi is irrelevant. E to the theta is a positive function. It's always positive. Right? Range of e to the x, 0 to infinity. It's also never 0. Right? So it's actually strictly positive. It's not non-negative, it's strictly positive. So we don't need the absolute values. What's the antiderivative of e to the theta?
You do it either way.
What's e to the 0?
1.
Length is e to the pi minus 1. Questions on the calculus of polar curves? There is technically a formula if you take a polar curve and rotate it about the x-axis, get a surface of revolution. There is a formula for surface area. It's extremely complicated. The integral is just ugly, so we don't cover it in Calc 2. I don't even think it's in the textbook, but there is technically a formula for it. So we've got 4 things that are coming up on Wednesday. Right? Math, you can now work on assignment 24. So that'll be due Wednesday. Second mathematics assignment, due Wednesday. I think that's an actual term reflection. You're reflecting on the term in general. That is due Wednesday, and then the final exam will be on Wednesday.
How long do we get on the final?
2 hours.
Do you know how many questions it is?
I forget, but it's 125 points. Should be more than, you should have enough time. 2 hours should be enough time for it.
Okay.
If you know what you're doing. If not, then 2 hours is not going to be enough time. But if you don't know what you're doing, it doesn't matter if you run out of time. Because you're clearly going to fail anyway because you don't know what you're doing.
And it covers everything.
It's comprehensive. I'm required to give comprehensive here. Is it 7? I think it's 17 questions. I think that's what it was.
Okay.
A lot of 5-pointers, so a lot of them should be quick.
Mhm.
So that will be on Wednesday. There is a greater emphasis on the new stuff, though. 50 points for the new stuff, and then 75 points for the old stuff, but broken into 3 quarters, so it's 25 per quarter. So it's a heavier emphasis on this new stuff that we did since the 3rd exam. Heavy emphasis on quarter 4. And that was what started with power series, right? So power series and analytic geometry is the heavier focus. And then just the other stuff. Any questions overall? For the 3 of you that managed to survive to the end.
There's only 3 of us right now.
Yeah, it looks like it. Now, does that mean that only the 3 of you are going to show up for the final? Not necessarily. But I actually have something to give back, don't I? Where is it? I believe all the solutions are posted online. I'm pretty sure I put up quiz 4 solutions. All right, so everything is online. I might even put up the final exam solutions after the exam is finished, so Wednesday. Probably go up Thursday morning, but I'll probably post those solutions as well. So maybe you'll have an idea of how you did before I actually grade them. And actually, I should actually have those graded on Thursday. So you should actually see your final grade Thursday night. Now, obviously, the college won't post it. I think the college posts it really late. Deadline is, oh God, what do I have? I have to have grades in by the 15th,
In 16, where's it out?
and then the registrar posts them on the 16th. So I don't think it matters how early I post them. I don't think registrar actually rolls them until the 16th. I could be mistaken, but you'll have it on Teams, so you'll know. Calc 2, according to many, the hardest calculus you take. So if you have to move on to Calc 3, maybe not as painful. Unless you're terrible at 3 dimensions, then it's going to suck. Calc 3 is actually my lowest grade of the 3 calcs. I aced Calc 2. Have a wonderful rest of your day. See you again Wednesday for the final. We'll be in this room 6 to 8.